Hello my dear students, I welcome you to NEET World. So we will be continuing our discussion on EAPCET question papers of 2025. Okay, so these are from AP EAPCET. Okay, and this is from May 20th paper. Okay, May 20th 2025 EAPCET AP EAPCET question paper we will be discussing. Okay, so here let us discuss about the questions from chemistry part first. See, we have started this paper yesterday and we have discussing the continuation part of it. I will show you questions here. Yeah. So hope you are following our daily classes, right? So let us see this. So here we have chemistry part. Okay, we have 40 questions in this. So out of 40 you need to answer all the questions and there is no negative marks for this exam, right? So it means you have to try all the questions and you have to be strictly follow the time for time management in this exam. Okay, so let us start with the first question. If a bullet of mass 2.2 grams sorry. See, here we have, if a bullet of mass 2.2 grams travels with a velocity of 3 into 10 power 4 centimeter per second inverse, its wavelength is. So how can we solve this question? Now what is the relation we have between mass, velocity and wavelength? And here they are also given value of this h. So what is the relation between them? So we have a relation between them like this, na? So lambda equals to h by mv. So de Broglie wave equation we have. So using this we can solve this question, right? So lambda equals to, what is the h value we have here? Substitute that 6.6 into 10 power minus 34 joule second inverse, joule second. Okay, and what about mass? Here we have given it as 2.2 grams now. So I am writing 2.2 grams. See, joules, this is in SI units, so we can also convert these grams into kgs by multiplying it with 10 power minus 3 kg. I am writing like this. Okay, and then next, what about velocity mentioned? So it is 3 into 10 power 4. Okay, so 3 into 10 power 4. Okay, centimeters we have, we need to write in the meters. So centimeters mean 10 power minus 2 meters I can write. Okay, multiplied with second inverse. Yes, that is what happening here. Okay, so these if you see, so joule second inverse, so meter, so second inverse, and this kg will be cancelled. We will be remaining with one more meter here from this joule. Okay, so now what are the other values? Here we have 2.2 into 3 gives 6.6. So it means it is 3 and here this 3 get cancelled. Okay, so what we are remaining with, lambda equals to, here 10 power minus 3, here 10 power minus 34, right? And here 10 power minus 2, 10 power 4. So this I can remove 10 power 2 times. Okay, and this one 10 power minus 3, 10 power 2 means here 10 power minus 1 we have. Okay, so this 10 power minus 1 I can remove here 10 power minus 33. So we got 10 power minus 33 meters is our wavelength of this particular bullet, right? So this bullet is having how much wavelength? Now it is having 10 power minus 33. That is what option number 4 here. Hope it is clear how we are solving this question, right? Is there any confusion here? No confusion, right? So option number 4 is correct answer for this question. Okay, right. So this is our option number 4 which is correct here. So let's move forward. So feel free to ask if you have any queries or any difficulties in solving this question. See, this question I have discussed in the last class also. Okay, so in the last session at the same time in the previous day we have discussed this question. Now you can give a try, and if you are unable to solve, you can go through that discussion, so you will get the answer from there. Okay, and even this one let us discuss now. This haven't discussed yesterday, today we will be discussing it. See, the electron gain enthalpy of chlorine is given. So electron gain enthalpy is how much? So minus 3.7 electron volt per atom. Okay, so electron volt per atom, electron volt per mole. Okay, how much of energy in kilocalorie is released when 7.1 gram of chlorine atoms are completely converted into Cl minus. See, here they have given this many grams, here they have given for mole. See, the electron gain enthalpy means what? When chlorine atom to the chlorine atom which is in gaseous state, when we add one electron, so it will become Cl minus ion, right? Okay, so now during this process it will release some energy. How much energy it is released? So this is 3.7 electron volt per mole. So what is the per mole weight for chlorine atom? So 1 mole of this chlorine atom, 1 mole of chlorine atom has 35.5 grams. Okay, this is the mole of this is the weight of 1 mole of chlorine atoms. Okay, so now for this many grams, what is the energy release? It is minus 3.7 electron volt. You have to understand this from this given data. Okay, so now what is the weight they have given? So they have given again 7.1 grams of chlorine atoms are given. Now how much amount of energy is released? This is value we need to calculate. This x value we need to calculate here. Okay, so now what I can do, just use the unitary method. So x will be equals to this minus 3.7 into 7.1 divided by, so 35.5, that's it. So if you do like this, you will get some answer here. Okay, so this answer will be in what units? This is in electron volt. Okay, so this 7.5 5s if you do, so you will get 35.5. Okay, so this is what the value in electron volt, but we want our answer should be in kilocalorie per mole. So x can be taken as minus 3.7, okay, by 5. So 1 electron volt equals to, they given 1 electron volt equals to 23 kilocalorie. So wherever you have electron volt, there will be representing with 33 kilocalorie, because our answer should be in kilocalories as they asked us. Okay, in kilocalorie. Okay, so this is 5 ones are 5 fours are 20, we have 3, so 36. Okay, 5 6 are 30. So that's it. So by multiplying that, so you will be getting minus 17.02 kilocalorie will be your answer. Hope it is clear how easily we have solved this question. I hope it is went very well without any confusions, right? So this is the steps you need to follow whenever they ask this kind of questions. Okay, so now they may also ask for ionization energy. In the next exam they may ask for ionization energies, giving ionization energy for one atom, like for 1 mole, and they may ask for what is the ionization energy for some x grams or some y grams or 1 atom or 2 atoms, like that. Okay, if they ask per atom or 5 atoms, like that, see 1 mole contains Avogadro number of atoms, no? So use that Avogadro number requires this much energy, then x atoms require how much energy, like that you need to calculate. Hope it is also clear. Now if it is clear, just click on the like button. Yes, I will be looking into it, and if you have any queries, ask me in the comment box. Yeah. This question again molecular orbital theory based question. Yesterday's class only we have solved this. Okay, so you can give a try for this, and if you have any confusion, just watch previous live session. I mean yesterday's live session, you have answer in that. Okay, I have explained in that, and even this question also discussed yesterday itself. Now here we have one more question which we haven't discussed. Now look here, a gaseous mixture contains dihydrogen, dioxygen. The total pressure is pressure of this mixture is how much? 2 bar. So P total is how much they given? So P total is 2 bar. Write it. Then next, the weight percentage of dihydrogen in the mixture is 33 point. See, weight percentage means what? Weight percentage means weight of hydrogen by total weight of the mixture into 100, right? So what is the mixture here? We have hydrogen plus oxygen. So that is nothing but they mention it as 33.33%. So from this, weight of hydrogen can be taken as weight of hydrogen or weight fraction of hydrogen can be taken as how much? So 1 by like this I am taking 1 by 3 I am using. Why I am using 1 by 3? See, 1 by 3 is nothing but, so I can remove this as like 0 point if I put, so it will be 3 times, okay, like 10 you will be getting like 3.33 like this now, into 100 if you do, so that will be giving us 33.33. So that's why from using this I have taken this. Okay, similarly now mixture contains hydrogen and oxygen only now, so weight of oxygen I can consider it as 1 by this is 1 by 3 means it should be 2 by 3. Total sum should be 1. So 1 by 3 plus 2 by 3, it should be equals to 1 now. So like that I have taken weight fraction, using weight fraction I have taken it. Okay, now I hope it is clear. Now we got weights of this H2 and O2. So from this what is the approximate partial pressure of dihydrogen? See, how can we calculate partial pressure? Partial pressure of a gas equals to P gas equals to partial pressure of a ith gas, let us say, mole fraction of that ith gas into total pressure. So what is the total pressure? Here we have 2 bar we have. Now I want to calculate it for hydrogen gas na, PH2, it means partial pressure of hydrogen gas equals to total pressure, that is 2 bar is given, multiplied with mole fraction of that gas, mole fraction of H2. So mole fraction of H2 means, what you have to take, so number of moles of H2 by total number of moles. Okay, so how many moles we have? From the given weight we can calculate the total number of moles. So how can we calculate this? NH2 I am writing, so given weight is 1 by 3 by its molar mass. What is its molar mass for hydrogen? It is 2 na, so 1 by 3 into 2, so this is 1 by 6 I am taking. Similarly number of moles of O2 I am writing, so 2 by 3 into 32 I am writing. Hope it is clear. Why 32? It is the molar mass of oxygen. Okay, so hello sir, Kallu is here. Sir, chemistry paper ka is बार NCERT से ही आ गया क्या? Yeah, so Kallu, this paper is engineering and agriculture paper, which is happens it is a state level entrance exam conducted in AP and Telangana states. Okay, so we will be discussing about the NEET papers also in the upcoming sessions. Yeah, so next this is about number of moles of N2 and H2 we got. So from this how can we convert this mole fraction of H2? So number of moles of H2 means that is 1 by 6 I can write. Okay, and mole fraction of this means how much it is? 16 I am taking, so 1 into here I am writing 48. So this is what the value we got here, mole fraction we got. So take here 48, okay, mole fraction 48 by 6. Okay, so like this you can take 48 by 6 plus, so total you have to take now here. So let me take here, it is once again, so NH2 equals to 1 by 6. So this is the number of moles of hydrogen I have taken. N total means what? So number of moles of hydrogen, that is 1 by 6 plus 1 by 16 you have to take. Okay, so from this what you will get? So here 1 by 6 I am writing as it is. So here, so in this I am writing 16 plus 6, here I am writing 16 into 6. Okay, so like this you need to take. Okay, so finally what you will get? This 6 cancel, so 16 by 96 you will get, not 96, this is how much? So 24 you will get. Okay, so by simplifying this, so by substituting here PH2 will be, so 16 by 24, so whatever the value you got for this and into multiply with 2, so you will get a respective answer from here. So that will be how much here? 1.778. Hope it is clear, right? So let us move further. So now 2 moles of in 2 separate 1 liter flasks. See, in 2 separate 1 liter flasks, O2 and helium are present. Okay, so RMS velocity of O2 and helium is x and y respectively. The correct relation between x and y. So how can we do this? See, RMS velocity means what? U RMS I am writing. So that is nothing but root over 3 RT by M. That's it. So this is a formula you need to use here. So U RMS velocity of O2 is how much? So that is x. So I am taking for oxygen, it is as x equals to root over 3 RT by, what is the molar mass of oxygen? It is 32. Okay, take it like this. Okay, then next, what about helium gas they mentioned? It is y equals to root 3RT by, so what is the helium mass here we have to take, so that will be 4. Okay, like this you have to take. Now ratio of these two you can take. Okay, so what will be the ratio you will get? So X by Y equals to, okay, so here how much you will get? So see what they are asking, respective the correct relationship between X and Y. So what we can say, so X and Y here means, so you can take, they are saying in terms of X square, Y square. Now look at the options, like that we need to make. So I can just by squaring this both sides, what will get? X square by Y square means what? 3RT by 32 totally by 3RT by 4, right? So these 3RT cancel, so this is 8. Okay, so now what we got here? So X square by Y square equals to 1 by 8 we got, right? So now X square into 8 will be equals to Y square. So this is what the relation we got. So now look, do we have any option like that? Yes, here we have an option, Y square equals to 8X square, which is option number 2. See, Y square equals to 8X square, that is what the answer we got. So you can choose option number 2, right? Next, let us move further. Which are the following has highest mass? Again, so just number of moles is given, multiplied with molar mass, so you will get ozone as a maximum mass, which we discussed in the last class. So just give a try. If not able to solve, go through the previous class, previous live session. Okay. Next, here you tell me, again we have one important question, again based on what? Equilibrium constant. Sorry. So in a reaction, X gives rise to Y, both are in gaseous at equilibrium. The partial pressure of Y is 1/3 of the partial pressure of X. The standard Gibbs free energy here. See, standard Gibbs free energy formula is what? Delta G naught equals to, what is the relation between equilibrium and standard Gibbs free energy? Equilibrium constant and standard Gibbs free energy. Delta G naught equals to minus RT ln K. Right? K means equilibrium constant. Since they are gases, so I am taking it as Kp. Equilibrium constant in terms of partial pressures we need to take. Okay. So what they are saying, the partial pressure of Y is 1/3 of partial pressure of X. See, P of Y equals to 1/3 of partial pressure of X. That's it. This is the relation we have. So now, how can we write this Kp? So Kp for this equilibrium can be written as product concentration by partial pressure of product by partial pressure of reactant. So what is the partial pressure of product here? So Py by Px, that's it. This is what you need to take. So Kp value how much you will get? What is the Py here? They mentioned 1/3 of Px. So I am writing 1/3 of Px. In the place of Py I have written 1/3 of Px. So in the denominator we have already Px. So remove this Px, your Kp value is 1/3. Hope it is clear, right? Now substitute that value over here. So delta G naught will be equals to minus RT ln 1/3. So we have 1/3, can I write this as minus log 1/RT ln. So 3 power minus 1 we can write now. So minus 1 into minus. So it will be plus RT ln 3. So this is the answer that is given in the options. Yes. So look, RT ln 3. So delta G naught equals to R3 ln 3. So this is your answer. Okay. Hope it is clear without any confusions, right? So now if it is clear, just click on the like button once again. Okay, let's move further. Now here we have a general easy question. Look, they are saying 1 mole of an ideal gas is present in 1 liter vessel at T Kelvin. Its pressure is P atm. The vessel is divided into 2 equal halves. The pressure and volume in the each part respectively. See, let us understand by taking a diagram here. See, 1 mole of ideal gas present in this volume of container. Let us say this volume of this container is 1 liter and pressure is P atm. 1 liter volume, P atm pressure. Okay, so in this what we have? 1 mole ideal gas we have, 1 mole gas we have, ideal gas we have. So now whenever this, see what they did, the vessel is divided into 2 equal parts. Now what is the volume of this this vessel and this vessel? Since it is divided into two equal halves, they are not compressed, they just divided it. So divided means, so what happens here? So the volume becomes 1 by V, 1 by 2. It means it is divided into two parts now, separated into two parts. So volume, this is half, this is half. 1 liter means half and half. So half liter I am writing. Now pressure will remain the same only now, because if they compress the volume, then volume compress, so pressure volume decrease, so pressure increases, but they just separated them. So here also it will be P ATM, here also it will be P ATM. So pressure will be remain same, but volume changes to half. So P ATM is remains the same, pressure of the container remains same even after separation, the volume will be changes to half. So this is what you need to understand here. Okay, next let us move further. See, a vessel A contains 1 mole of H2 and I2, okay. In another vessel B contains 2 moles of H2 and I2. So both vessels are heated to same temperature till the equilibrium is established in both cases, okay. So there are two vessels in which number of moles are taken in different manner. So in one it is taken 1 mole, in another one is taken 2 moles. It means what? The concentration of gaseous substances are differ in two vessels, but temperature maintained is same, because see they mentioned same, it's heated to same temperature. So what is the equilibrium constant here? So how the equilibrium constant differ for both of these? See, we know equilibrium constant Kc, I am representing equilibrium constant as Kc. So Kc is independent of concentration, that depends only on what? So Kc, value of Kc is affected only by temperature, okay. If temperature changes, value of Kc also, equilibrium constant also changes, okay. Even the concentrations are same or different, no matter it is. If temperature is same, the values of equilibrium constant is both in all the cases. So both, see, in the equilibrium established in the first case in container A and container B will be having same Kc value, because their temperature is same in the both case at the equilibrium. Hope it is clear, because it is value of Kc will not depends upon the concentration, it depends only upon the temperature, okay. If temperature is different, value of Kc also different. That is the effect of temperature on equilibrium constant, okay. So now Kc will remain same in both cases. Where do we have option like that? Kc for A and B are equal. So this is third option is our answer for this question. So the remaining are incorrect. Hope it is also clear, right? Now this question in the last class we discussed based on what? Conjugate acid base theory, okay. So what they are saying, conjugate acid base of ammonia. So ammonia when accepts H plus, it becomes NH4 plus now. So that is the conjugate acid. So it will be having tetrahedral geometry. Conjugate base of ammonia is what? Just release one H plus from ammonia, it becomes NH2 minus, right? So that will be the having angular shape like water molecule. It will be having now bent or angular shape. So here we have angular. So option 2 is perfect answer for this. For more clear explanation, just go through the yesterday's discussion where I have discussed about this question clearly, okay. And then next, this is also based on diboron we discussed in the last class, okay. This color of the metals also discussed, right? Here which metal is used in the thermometer? I have told you that is gallium we can use, okay, at high temperatures. So buffer action in the blood will maintain the pH, right? That is also discussed, okay. Then next here, this question also discussed na. So monochlorination of dimethyl 2,2 dimethyl and 2,3 dimethyl butane will gives you what are the possible products. So I have explained, just take like this I told you, and take number of monochloro derivatives 2,2. It means the same position methyl groups are there. So this methyl contains same hydrogens now. So by replacing any of this hydrogen, we'll get this kind of product, okay. So that kind of product either I can replace from here or here or here, it will give this kind of single type of product only, okay. So this is one type of product. Now is there any hydrogen here? No hydrogens. Now here we have 2 hydrogens. By replacing any of this hydrogen, we will get what kind of product? So we will get this kind of product here, right? So this is second product, okay. And here what about this? Here we have one more methyl group. Now by replacing that, we will get a chlorine here. So this is third type of product, like this, okay. So these are the 3 different possible products we can obtain for 2,2 dimethyl butane. So what happens when we take 2,3 dimethyl? So 2,3 means here and here, okay. So these 4 methyl groups are of same. By replacing any of the hydrogen, will give one kind of product, that I am taking it as 1. And here we have one hydrogen, and here also we have one hydrogen. These 2 are same. By replacing any of that one hydrogen, we get a monohalogenated product that will be of same type. So that is another one. So total possibility here for this is 2, for this is 3. So you can go with option number 1. So read the question, number of monochloro derivative possible for, okay. So this is the correct answer, okay. So now if they ask, actually if they ask for stereochemistry point of view also, so here you have a chiral center here. So chiral center containing compounds will be, this will be having one chiral center now. It means it can have R configuration and it can have S configuration. In this means if we consider stereoisomers also, then the answer in this case will be 4. Okay, in the first case for 2,2 dimethyl butane will be 4, but they haven't told about anything about stereochemistry point of view. So we will be going with normal answer, just structural isomers, that is 3, 2. Hope it is clear. Next, this we discussed in the last class only. Yeah. Here we have a question from osmotic pressure. So can you do this? How can we do this? The osmotic pressure of 0.01 molar solution of electrolyte is found to be 0.65 bar. Okay. So at temperature is mentioned 27. The Van der Waals factor for this electrolyte. So pi is the Van der Waals osmotic pressure, we can indicate. So will be equals to ICMST. So what is this I here? Van der Waals factor. That is what we need to find in this question. Okay. Now Cm means molar concentration, S means universal gas constant value, you can take like this, okay. T is the temperature mentioned. So this is 0.65, pi value given, that is in bars, okay, will be equals to I into, what is the molar concentration they mentioned? So 0.01, so 10 power minus 2 I can write, molar, okay. S is how much? 0.083 into, this should be in the bar, liter, Kelvin inverse, mole inverse, okay, into what is the temperature mentioned? 27. So do not take in 27, you just take 273 plus 27 gives 300 Kelvin, okay. So you can take 300 Kelvin. So Kelvin cancel, okay. Molar means mole also cancel, liter also cancel, here bar also cancel. So there is no units remaining here. So we need to find this I value here, that's it, okay. So here 10, here 2 zeros are there, I am removing this, okay. Then next what we have here, 65 into 10 power minus 2 equals to I into, so 8.3 into 10 power minus 2 into 3 we have. So this I value we need to find now, this I am removing this, see 3 3s are 9, 24, see 24, so 24.9 means can I take 25? Yes, we can take 25. So here we have 65 equals to 25 into I. So I value 65 by 25 you can take almost. So this by simplifying how much you will get? This is 2 times. So here we have 2 options with 2 times. I mean we are remaining with 15. So 0.0. So we will get 2.6 as your most appropriate answer for this question. Hope it is also clear what the concept we need to use here. Just use the formula of osmotic pressure and include the I value. You can include the I symbol here, you will get the I value there, right. Hope it is clear. So first option is correct. Next, what about this question? This is from Raoult's law, right. So ideal behavior, non-ideal behavior. So at 298 Kelvin, liquid A solute, that is, forms an ideal solution with liquid B solvent B is solvent. The following graph is obtained for this solution. So now what they are saying, so y means this y axis here, what we have, that is vapor pressure. So x is what we will indicate here, will be indicating mole fraction, right? So this will be indicated for mole fraction, and here it is what, for solvent, here we will be using. So now they are asking about identify the correct statement about this graph. X axis represents mole fraction of A. So A is what, solute here. So point Z represents the vapor pressure of pure solvent S. So here we will be taking solute, here we will be taking solvent. So this point Z, this is correct only, no? Z represents what mole fraction of solvent, it will be represents. So represents vapor. So vapor pressure of solvent, it will be representing. Here X represents mole fraction of solvent, it will be representing. So X represents mole fraction of B. So this side, mole fraction of B. So option 2, 3 are correct and not the 1. Okay. Next. Yeah. So take this question as homework from electrochemistry, and we'll be discussing this question in the upcoming session. So how can we solve? When 3 amperes of current was passed through an aqueous solution of salt of a metal M having atomic weight this much for 1 hour, okay, this much amount of substance is deposited, okay, deposited at cathode. What is the value of N? Okay, what is the value of N? So how can we do this? So just use the Faraday's first law. So weight, the quantity of substance deposited. So weight of substance deposited will be directly proportional to the quantity of charge current passed through it, you can say. So weight equals to, remove this proportionality, you will get Z into charge, I can say I into T. Okay. So then next substitute this Z means what? Equivalent weight by Faraday into I into T. So weight is given, okay. So equivalent weight means what? Weight by its n factor, molecular weight by its n factor. So you can say molecular weight by its n factor into Faraday into I into T. So now just substitute this value and tell me the answer for this question in the comment box. Okay. So what you need to find? You just need to find this n value here, that's it. So F value, how much they mentioned, this much you put here, you will get the answer, and tell me in the comment box. If not, I will be explaining the next session. Now you will be having the physics continuous session here, okay. So Vignesh sir will take that session. Okay, thank you for watching. Stay connected with us. Thank you. అవునా